So moving on to the next page here, there's a bunch of phrases related to inequalities here that sometimes get confused. And so when we have this in class, we'll typically do an exercise here where you try to fill in all of those statements under the correct symbol. And it would be good for you if you actually pause the video here to see if you could do that. So if someone wants to pause the video here so you can give this yourself or the students a couple minutes to write the statements they think go underneath each symbol, that would be great. But we'll go ahead and take a look at what we have here. So greater than, all right, well that one's pretty straightforward. Hopefully you put it under this one here because greater than is exactly what that symbol means as we read it from left to right. More than or equal to. So more than or equal to, that's greater than or equal to would be this one over here. Less than or equal to would be the third statement. More than, okay, so that's just a different way of saying greater than. So all these phrases are used in different contexts here, but sometimes we get tripped up with them. So let's see how we keep doing here. So less than, that's literally what that is. Okay, so here's the ones that start to get confused. No more than. If it cannot be more than, then it has to be less than, but it could also be equal to. So no more than is the same thing as saying less than or equal to. You just can't be more than that number. So if I'm giving out Snickers bars on Halloween, I'm going to say I'm going to give you no more than 2 Snickers bars. So you could use 2 Snickers bars or 1 Snickers bar, but you just can't have 3, all right? So no more than. No less than. If it cannot be less than, then it could be greater than, but it could also be equal to. It just can't be less than. It could be anything but less than. So greater than or equal to. At least. This is another one, because you hear the word least and you think less sometimes. But at least actually means greater than or equal to. If I'm going to give you at least 2 Snickers bars on Halloween, then I'm going to give you 2, but I might give you 3. I might even give you 4, all right? Or I might give myself 4 because, you know, I love Snickers bars. Fewer than, okay, so that's a little bit more straightforward. Fewer than is just another way of saying less than. And here's another one at the end here that is sometimes mixed up. At most, so this is kind of like the one at least, but at most means less than or equal to. I'm going to give you at most 3 Snickers bars, all right? That means 3 is the top, all right? That's the most, but I might give you 2, I might give you 1. I'm just gonna give you at most, so less than or equal to. All right, so those phrases sometimes can get confusing. It's important to just kind of drill those phrases. All right, so just like we solve equations, we can solve inequalities, and they follow the same general solving steps when we go through the, at least with my students, DC-MAM steps, distributive property, combine like terms, move variables, add, subtract, undo, multiply, divide, undo. Follows those same steps. But there is a little twist that sometimes happens. We'll mention that when we get to it. So draw the little line down, kind of like the equal sign, only it's a greater than symbol here. We're going to undo addition with subtraction. So something plus 12 has to be greater than 8. Subtract 12 from both sides, bring down the x. 8 minus 12 is negative 4. Now, I'm just going to bring down the symbol as well. So we're saying anything greater than negative 4 is a solution. So what I want you to do is to represent that visually, we're going to put the negative 4 in the middle of our number line. And then we're going to put numbers greater than negative 4 going to the right. Now that means we're getting closer to the positive numbers, and less than negative 4 to the left. That means we're getting more negative, so it's getting colder outside in the Minnesota January winter. All right, so if it has to be greater than -4, that means -4 is not a solution, so we're going to represent that with an open circle, but anything greater than -4 is a solution, so there should be an arrow going to the right. So that's how we could visually show our solutions. So we could try listing out all of the solutions, like -3 is greater than 4, 2 is greater than 4, 1,000 is greater than 4. But there would be an infinite amount of solutions that are possible. So we can't really represent all the solutions. We can give some examples of solutions, but using the number line is a way that we can really represent that. So that's how the graph actually is super helpful for showing solutions to inequalities. All right, let's do the next one. All right, so we're going to add 8 to both sides here. To undo subtracting of 8, we're going to use the variable m, and 22 plus 8 is 30. Now that is literally saying 30 is greater than m, but I usually like to just flip that around. Okay, so I'm going to be careful with that word flip. I'm going to change that so that the variable is on the left. The mouth still opens up to the 30 though. So this is the same thing. So 30 is greater than m is the same thing as saying m is less than 30. These two really are saying the same thing. But I much prefer this, and if you did that other one, that's fine. It wouldn't be wrong, because usually when we're looking at the solutions, we want to start with the variable. So we want the variable kind of on the left side. So if it isn't on the left side, I like to rewrite it. But notice this means the same thing. The mouth is still opening up to the 30 in both cases, so this really does mean the same thing. Let's put 30 in the middle of our number line. Let's put some numbers greater than it and less than it. Again, 30 is not a solution, so we're going to use an open circle, but anything less than 30 is a solution, and that is the same thing as saying 30 is greater than all of the solutions. That's true. 30 is greater than 29. 30 is greater than 28. Okay? All right, this next one. So -7x really means -7 times x. So we're going to undo multiplication by dividing both sides by -7. So here's where there's a little twist. So when we divide by a negative, that is actually going to flip our inequality symbol. So I want you to write that in here. Flip the symbol when we divide or multiply by a negative. We know if we put a negative sign in front of something, that flips its value. So if you put a negative sign in front of a 3, it changes it to a -3. If you put a negative sign in front of a -3, it changes to a +3. Negative signs, when we multiply or divide, flip the value of the number, right? When we add a negative or subtract a negative, that does not necessarily change the number from positive to negative. We might still be in the negatives, we might still be in the positives, but when we multiply or divide by a negative, it does actually flip the symbol. So that is the little twist that you're going to have here when you're solving with inequalities. If you multiply or divide by a negative, you need to flip that inequality symbol. All right? See if you can remember that. So let's put -3 in the middle of our number line. Let's put some numbers that are less than that, some numbers that are greater than that, closer to 0. Closer to the positives. This time, though, we're going to fill in our circle on the -3 because -3 is a possible solution. And also, anything greater than -3 is a solution. So the arrow should be pointing to the right. Moving down, we got a two-step equation here in number 4. So we're going to subtract 4 from both sides. We're going to undo the add subtract first. We're going to bring down the 5h is greater than or equal to 15. Notice I subtracted 4. I did not multiply or divide by anything that is negative there, so I don't need to flip the symbol. So 5 times something equals 15. So we're going to undo that multiplication by dividing both sides by 5. H is greater than or equal to 3. Again, no flipping of the symbol in here because I did not multiply or divide by a negative. All right, let's put 3 in the middle of our number line. Let's put some numbers that are greater than it, some numbers that are less than that, and then we're going to fill in 3 on the number line because 3 is a solution, and also anything greater than 3 is a solution. Okay, all right, well, let's see here. Actually, on this one, you'll notice in our DC-MAM steps, one of the things that we do before we do the add, subtract, undo is typically we get our variables together on the same side of the equation. So we move the variables together. So in this case, I've got n's on both sides of the equation. So let's move the 3n to the right side by subtracting it over. And that leaves us with 6 is less than or equal to 1n, or just plain old n. Okay, so that's basically our solution. Now, just like in, let's see, the problem above it, number 2, I'm just going to rewrite this as n is greater than or equal to 6. That is not flipping the symbol per se. That's just rewriting it so that the variable is on the left side. Notice the mouth is still opening up towards the n in both of these. So I didn't flip the symbol in the same way as I did in number 3. But now I'm less likely to make a mistake when I'm graphing this. So 6 is in the middle of our number line, some numbers above it, some numbers that are less than that. 6 is included in the solution, and also anything greater than 6 is. Okay? So, and that's the same thing as saying 6 is less than or equal to all of the solutions. That is true. So we're going to look at the next one here. I'm going to subtract 5 from both sides. We got n is, all right, so n divided by -2 is greater than or equal to 3. And then, all right, so we're going to subtract 5 from both sides. So n divided by -2, so we're going to multiply to undo the division here. And we're going to multiply both sides by -2. So -2n divided by -2, remember that essentially cancels out the dividing. So we undo that dividing of -2. But what also happens here is that this symbol is going to get flipped again. So that's going to move to a less than or equal to, because again, if I multiply or divide by a negative, we're going to flip the symbol. And in this case, I divided by a negative, didn't multiply by a negative, divided by a negative, so that did flip the symbol. So -6 is in the middle of our number line, some numbers that are above it, some numbers that are less than that. -6 is right in the middle here. And anything less than or equal to -6 is a solution. So remember, the only time we flip the inequality symbol is when we multiply or divide by a negative number. So flip when we multiply or divide by a negative number. We do not do that when we add or subtract. That is not going to change the value of our number from a positive to a negative necessarily. All right, but when we multiply or divide by a negative, it automatically changes the value of the number from a positive to a negative or a negative to a positive, and so therefore we need to flip our inequality symbol.